For topic two, we're going to talk very specifically about triangles. So remember, a triangle is a type of polygon, which is a flat enclosed figure made up of at least three sides. So now we're going to talk about exactly three sides, which is a triangle. And there are four, like, kind of basic types of triangles, okay? So we've got several definitions here. Well, four definitions to be exact. We have an equilateral triangle. Now, typically you would follow up the descriptor word here with just triangle. So an equilateral triangle is a situation where all sides are congruent and all angles are congruent. So in the previous video, we talked about a regular polygon. A regular polygon is one where all of the sides are the same length and all of the angles on the inside are the same measure. The regular triangle, if we're talking regular polygons, would be the equilateral. Okay. Next, we have an isosceles. I always forget how to spell this one, so don't worry about your spelling, just as long as you get the gist of it. But an isosceles triangle, we have two angles that are going to match and two sides that are going to match. So two of your sides are going to have the same length. And then because those two sides are the same length, they're going to create two angles that are also going to have the same length. So you're going to have another side and another angle that don't match, but two of them will. And then we have a scalene. So a scalene triangle is one where no sides or angles are congruent. So you're going to have three sides that are different lengths, three angles that are different measures. And then finally, you can have a right triangle. Now, you have different types of right triangles. So you can have a right triangle that is either a right scalene or a right isosceles. What initially makes a right triangle is that it must contain a right angle. Okay. So, and this is actually like a really big deal. If you end up taking like a trigonometry class, we talk a lot about these right scalene or right isosceles triangles. So, you have to have a right angle. So we could have two sides that are exactly the same length that create that right angle. And then what happens is the other two angles, those are going to be the same, and they would have to be 45 degrees. So this is a right isosceles triangle. It has two sides that are the same length. Those are the two that make up the right angle. And then it has two angles that match, which are like the other two angles. Then you can have what's called a right scalene. So we have three sides that are definitely not the same length. Okay, and then we can have these two angles here that are not the same measure. So this one has some measure, this one has some other measure. Okay, this length has some measure, this side has some other measure. Okay, so well, let me label those differently. Now, one really classic type of right scalene triangle is a 30, 60, 90 triangle, where one of the angles is 30 degrees, one is 60, and then of course the third one is 90. So again, if you were to take a trigonometry class, you would talk much more about that. But we would say this is a right scalene triangle. Okay, and we can't say definitively what those other two angles are. They could be like really anything as long as those other two angles add up to 90 degrees. Okay, but there you have it. Those are the four types of triangles that we can talk about. And so now we want to label each of these. So it says name each type of triangle and then label the base and the height. I'll explain what the base and the height are once we kind of get into this. Okay, so I'm going to not do these in order. So the first triangle I want to talk about is the equilateral. So the equilateral triangle is the one where all of the sides have the same length and all of those interior angles have the same measure. So this one right here, part D, is our equilateral triangle. Okay. And we can see that the sides all have the same measure. We'll put these little tick marks in there, and as long as sides have matching tick marks, that indicates that they have the same measure. So all three sides have the same measure, which would kind of by default mean all of these angles inside would also have the same measure. So just for fun, this is not part of the question, but for fun, I sometimes say for funsies. We have three angles. We have this definition. It's something that we haven't really talked about here, but the three angles of a triangle must add up to 180 degrees. And there's lots of information out there about this. I'm just telling you, so right now, just take me at my word. So we know that the three angles in a triangle have a sum of 180. So to figure out the angle measure in an equilateral triangle, we just divide it by 3. So each of these angles would be 60 degrees. Okay, so we talked a little bit about angles when I introduced the the right scalene, the right isosceles. So what I didn't tell you is the three angles of a triangle really do have to measure 180. So now, that might make a little bit more sense. So that's the angle measure for an equilateral triangle. Now the question says label the base and the height. So whatever the triangle sits on, you can kind of call it its base. So we're going to say this is the base. And then the height is from the highest point on the triangle perpendicular to the base. Now, we already know two lines are perpendicular if they intersect, forming right angles. So essentially, if I kind of erase all this work that's inside my triangle, if I go from this top point here straight down to what I'm calling the base, I would then get height. So I'm just going to call it H for height because I don't have room to write out the whole word. So there you have it. That is an equilateral triangle, and we have labeled its base and its height. And then we also talked a little bit more. We talked about the fact that three angles in a triangle have to add up to 180. And if you're dealing with specifically an equilateral triangle, we know all three angles have the same measure, so they would all have to have a measure of 60 degrees. Okay, now the next type of triangle that we talked about was an isosceles triangle. So that's the one that's here in part C. So this is the isosceles. I told you I never can remember how to spell this. The S's and the C's all get jumbled up. Isosceles. So this is our isosceles triangle. And what we know is that two sides have the same measure. So these two sides have the same measure. So that means these two angles. Now, this is kind of a little bit higher thinking than we need to worry about right now. But the sides and the angles opposite them, they're kind of connected. Okay. There's like a proportional thing that happens. We don't have to get too worried about it. But this side over here is opposite this angle. And then this side on the left is opposite this angle. So these are the two angles that are going to end up having the same measure. Okay. This third angle up at the top, it's the oddball. It's the one that's going to be different. Okay. And then this bottom side down here, it's the oddball. It's the one that has a different measure. Okay. Now let's erase some of that work in here so that we can build our base and our height. I'm going to keep these two angles. Okay. Now the triangle is sitting on its base. And then just like in the equilateral, if we go perpendicular from the highest point down to the base, we get our height. Okay. Now, the third type of triangle we talked about was the scalene triangle. Okay. And that is part B. So this is our scalene triangle. What we know about a scalene triangle is that no two sides have the same measure, no two angles have the same measure. So three different side lengths, three different angle measures. Okay. Now, if we say that the height of the triangle is sitting on its base, then the height is going to be from this point down to the base. So from the base, whichever side you have it sitting on, find the point that's highest or that's farthest away from that, and then just drop a line perpendicular to the base, and that becomes your height. Okay? And then finally, the fourth type of triangle we talked about was a right triangle. And what we know about a right triangle is it has to have a right angle. And I told you in a previous video or somewhere that this right here, this little box they put in the corner, this tells us we have a right angle. We can never assume it's a right angle because something could look like it's a right angle, but maybe it's 89 degrees or it's 91 degrees. It's not exactly 90 degrees. So you have to look for that little box in the corner to know for sure it's a right angle. So this is our right triangle. If we say our triangle is sitting on its base, then the other leg right here, this right here, would end up being the height. So whatever you say is the base, go from the point that's highest or furthest away from the base and then drop just a perpendicular, straight line down perpendicular to the base, and that becomes your height. Okay, so those are our triangles. I don't know, do we have more? Yes, we have more. So I finally officially tell you in this example 3, I have note the sum of the three angles of a triangle is 180 degrees. We have to know that, okay? So what we're going to do in example 3 is find the you can tell I was doing different things here. I'm really sorry. There's a typo. It says find the sum of the missing angle. Well, you're not finding the sum of the missing angle. You're finding the value of the missing angle. So fix that right there. So find the value of the missing angle. I was probably going to say something like find the sum of the three angles or something and then change my mind. Okay, so we know that the three angles inside this triangle, they have to equal 180 degrees. So we're told that this angle right here is 110. We're told this little angle is 25. So what is left over for angle X? So all we have to do is say X is going to equal 180 minus the 25. and minus the 110 that have already been used. I'm going to use a calculator to do my side work here. So I'm going to take 180, subtract 25, and then subtract 110. And I get that x is 45 degrees. So this is the angle measure for this little guy over here. Okay? Now, finally, for part B, we're again going to be finding the value of the missing angle. So we know that the three angles in a triangle have to equal 180. We are told that this little angle is 25, and they don't give us a value, but we have this little box in the corner. And what does this little box in the corner mean? Well, it means this angle has to have a measure of 90 degrees. So then I can say, well, y is going to equal 180 because we know the three have to add to 180. We're going to subtract the 90 that's already been used. We're also going to subtract the 25. Whatever is left over is going to be the value of y. So 180 minus 90 minus 25, and we get 65 degrees. So this measure right here is 65 degrees. So finding the measure of one missing angle in a triangle is really easy as long as the other two measures are given to you, okay? And in something like example B, don't feel like you're missing information. They're never going to tell you that that little corner, when they put that little box in the corner, they're never going to say it's 90 degrees. It's just kind of like one of those things that you need to learn and remember and know. So when you have the little box in the corner, it means you're dealing with a 90-degree angle. All right, so that's it for triangles. In the next video, we're going to talk about quadrilaterals.